Right. Okay, super. So let's just recap quickly. So finding the derivative. So if you have something of the form kx to the n, remember that your derivative is nk x to the n minus 1. Right. So for example, y equals 5x cubed, your derivative, you bring the power forward and multiply. So 3 times 5, 15. Keep the x and then subtract 1 from the power. I'm sorry, guys. I'm battling with a bit of a bad cold. So excuse if I cough all the time. All right. And if you have something like minus a half x to the minus 2, your derivative, if you bring the power forward, will be positive. And 2 times a half is 1. And then x to the minus 2 minus 1 is minus 3. Which brings me to something very important. We don't like the negative powers. So please, please be meticulous about making your powers positive. It really helps you in the long run. So remember, there's an invisible 1 in front. To make that power positive, these two are glued together. You can't separate the x and the 3. All you can do is change the sign, and you dive away from what it's joined to. So 1 over. And this whole thing moves to the bottom, and the power becomes positive. Right. Okay, so in essence, the power rule, that is how it works, okay? But there are 2 little subsidiaries of the power rule. The one is that the derivative of kx is equal to k. So in other words, if I only have an x term, x to the invisible 1, then the derivative of that term is its coefficient. Whatever's in front is the derivative. And it follows directly from this rule. So, for example, if I had y equals minus 2x, then my derivative, because it's just an x to an invisible 1, the derivative of an x term is its coefficient. Right. And then another subsidiary is that the derivative is 0. Right? So, for example, if I y equals 3/4, because 3/4 has no x, it's just a constant, its derivative will be 0. And alongside that, just remember that if you had y equals pi, pi is a constant. So the derivative of pi is 0. So these are the rules, 3 rules, 1, 2, and the original one. The third one is the general one. And these 2 to learn them as 3 separate ones. Another intuitive, have a string able to find the derivative subtracted. I can quite easily just go and find the derivative, and then that will be my answer. So the derivative of 2x of an x term is its coefficient. So that will be 2. And then a power moves forward. So it'll become minus 2. X remains. And I subtract 1. 2 minus 1 is 1, which I don't need to write. And then plus the derivative of a constant, which is 0. And I don't need to write plus 0. Okay? So my derivative is simply that. So intuitively, I can add and subtract terms and find the derivatives by also adding and subtracting them. Then, very importantly, if you are ever given a surd form, so in other words, x to a power and the root of that. Okay, so the kth root of x to the n, the derivative cannot be found until you change this to an x to a fractional power. All right? So how do we work out what that fraction is? Something over something. It is the power, the existing power over the root. And that's it, unless you first change it to a fractional power. Because then you can go ahead and use your original derivative, the general derivative. Right, so in other words, it would be bringing the power forward, keeping the x, and then taking the existing power and subtracting 1. All right. So let's do an example of that. I'm going to do it right here. I'm going to choose an easier one. The cube root of x to the 4. If I wanted to find the derivative of that, because it's a third form, I first need to change it to a fractional power. Right, so the power over the root. And then I am ready to take the derivative. So bring the power forward. There's a 1 in front. 1 times 4 over 3 is 4 over 3. Keep the x and subtract 1. 4 over 3 minus 1 is a third. Right? And then, very importantly, and I'm pedantic about this, please make sure that you change the fractional power back to third form. Okay, so power over root. X to the power is on top, so it's a 1, invisible 1, and the root is the bottom, so the cube root. So your final answer is written back in third form. So get into the habit of doing that. It's a very useful tool when it comes to simplifying. So often in an exam question, they will ask you to find the derivative, and they might actually specify that you need to rewrite it in third form, the answer. And if you always do it, even if they don't ask you to, then you will always be used to rewriting it in third form. So it won't be anything new. You'll be so used to it that it will be second nature. So it's important to do that. All right, I feel quite strongly about it. And then the next one that I want you to do is the similar one, but the powers are going to be different. All right, so there's something like the fourth root of x cubed. Guys, somebody's writing on the whiteboard. Please don't, because it's a bit distracting. Thanks so much.
Dianne,
well, not distracting for me.
If you click in your options on participants or something at the top of your screen, no, it's at the top of your screen where you have your annotate, you have an option to stop anybody from annotating. There is an option.
I do.
Okay, so if you stop annotating clear, it's all gone. Your signal's a lot better. Can I just quickly comment? I've had a comment from somebody saying, can you slow down a bit because they haven't yet done this? So maybe go back just a little bit.
Cool.
Okay, have you managed to stop the annotate?
I'm going to write now.
Brilliant.
It's normally on this panel, but it's disabled. There we go. Participants and annotation. Oh, that is surprising. It's already the end of May, and you guys have not done calculus. That is amazing. So I'm going to go back and then just go through it slowly, okay? All right. Okay, so y equals kx to the n. This is what your function will look like, okay? This is generally called the power rule because it is x to the something, x to a number, okay? So it'll be a number, x to a number. And that is really the only derivative that you do at school in the South African syllabus. So when you want to find the derivative of such a function, of a power function, what you do is you bring the power forward. So n times k, you keep the base x, and you subtract 1 from the power. Right. So nk x to the n minus 1. And as an example, it would look something like this. Something x to the something. That is a power function. So we use the power rule for derivatives, which says bring the power forward and multiply. So 3 times 5 is 15. X to the, and we subtract 1 from the power. 3 minus 1 is 2. Okay, power forward, 3 times 5, 15, x to the 3 minus 1 is 2. And that is in its absolute simplest form. There's nothing else you can do to simplify something that looks like that. Right, another example would be minus a half x to the minus 2. It's something x to the something. So again, it's a power function. So we use the power rule. We bring the power forward. Minus 2 times minus a half. Now, of course, you can use the calculator to do that. I would like to think that most of you would be comfortable actually physically working it out. So minus 2 times minus a half. That is over 1, so the 2's will cancel. A minus times a minus is a plus 1. But if you put that into the calculator, you'll get 1, right? Which I don't need to write. I keep the base x, and then I subtract 1 from the power. Minus 2 minus 1 is minus 3. So 1x to the minus 3. Power forward, multiply. Write down the answer, x to the, and subtract 1. And then I do not like to keep negative powers as a final answer. So what I do is, remember when we have negative powers, we use that dive rule. We dive away from what it's joined to. It's joined to an invisible 1. So it will be 1. And that x to the minus 3 dives under and becomes x to the 3. The only thing that changes is the sign of the minus 3. It becomes a positive. Right. And then as a result of this power rule, there are another 2 rules that follow directly from the power rule. And that's the derivative of just something x. So the x is just x to the invisible 1. In that case, the derivative of something x is the something that is in front, the coefficient of x. So for example, y equals minus 2x. It's just an x to the 1 term. So its derivative is its coefficient, minus 2. The derivative of a constant is 0. A constant is anything without an x, okay? So like y equals 3/4, or y equals 5, y equals minus 10, y equals minus a half. The derivative of a constant is 0. And I just pointed out that pi is also a constant. So if you had to find the derivative of pi, you're going pi is a constant, and the derivative of a constant is 0. But don't worry, I'm going to be doing lots more examples within the other examples that I'm going to be doing. Okay, so these are just your basics, okay? This is your basic power rule. All right, and then I pointed out that if you have a string of terms being added and subtracted, that you can take the derivative of each separately and also then add and subtracting. So it's quite intuitive. Right, so the first term, the derivative of 2x, it's just an x term, x to invisible 1, and the derivative of an x term is its coefficient, so it's 2. And then the derivative of minus x squared, you bring the power forward, so it's minus 2 x to the, and 2 minus 1 is 1. I'll do a bunch of these examples just to concrete it. And then plus the derivative of pi. Pi is a constant, and the derivative of a constant is 0. So it's plus 0. All right, so that would be your derivative. And then what I also wanted to point out was that if they were to give you the derivative of a third, right, x to a power kth rooted, oh, sorry. Oh, I've got such a cold, I'm sorry. I'm hoping that my voice will hold for the lesson. Right, so I can always rewrite third form without the third. And I mean, you know that from, I think you do it, the first time you do it is in grade 9. Remember, you write down the base, you keep the power on top, over, and whatever the root is goes at the bottom. So this power is always a fraction, and it's the power over the root, n over k. Then I have it in the form of a power, x to a power, which means if I want the derivative, I bring the power forward. So the n over k moves forward, x to the power minus 1. All right, and then we did an example. Let me see if I can run this out. Yeah, I can. So if I did an example like the cube root of x to the 4, I'd immediately say, well, I have no rule that has a third to find a derivative. So I need to rewrite the third as a fractional power. Power over root, 4 over 3 in the power. And then how do I find the derivative? I move the power forward and subtract 1. Okay, 4 over 3 minus 1 would be 1 over 3. Okay, remember you can work out 4 over 3 minus 1 on a calculator, or you could do it manually. So remember, if you need to write the NBT, you need to know how to do it manually because there's no calculator allowed. Okay, so that LCD is fine, so it stays 4. But here you need it to multiply by 3. So if you multiply the denominator by 3, you do the same on top. 1 times 3 is 3. 4 minus 3 is 1. Okay, so 1 over 3. And then please just, I stress that you need to rewrite the x to the fractional power back as a third. So instead of going that way now, we're now going to go the other way. So we're going to go from x to the n over k back. So remember, the power is on top and the root is at the bottom. Okay, the power is on top. That's my power, that's my root. The power of x is 1, invisible 1, and the root is 3. I obviously don't need to write x to the 1. In fact, I don't write x to the 1. I just write x. But I'm going to be doing lots of examples, so. Right. Okay, so let's do a bunch of these. I just want to carry on with the third one first. So what I was planning to do was something like this. Right, so if you're given a third, immediately go, well, hang on, I can't find the derivative of third form. I need to change it to fractional power. So x to the power over root. Very important that you know that process. Okay? Now I'm ready to find the derivative. Okay? So I just want to elaborate this. I've been saying derivative and I've been putting y prime because I assumed that you guys had already done some calculus, okay? But that little prime, y to the prime, means the derivative of y. And this is one way of writing the derivative. So for now, let's stick to that. I'll also be showing you other ways that you can write a derivative, okay? So y prime means derivative. I need to find the derivative of an x to a power. So I bring the power forward, I keep my x base, and I subtract 1 from the power. 2/3 minus 1. 2 over 3 minus 1 over 1. My LCD of 3 and 1 is 3. That is already 3, so it stays 2. But this needed a 3 at the bottom, so a 3 on top. So it is minus a third. And this is precisely why I'm doing an example like this, because now I have a negative power. And remember what I said before, we don't like negative powers. All right, so if we look back at this example, x to the minus 3, we don't leave the answer like that. That is the derivative, but we do not leave it like that. We change it to a positive power. So we're going to be doing the same here. We're going to be changing this negative power to a positive power. Now I'm going to do this in a number of steps just to show you the theory of what you're doing. You obviously are not going to do this every single time, right? Because you'll be able to jump from there to the end. But I want to show you why it is like it is. This part, the x to the minus third, you will agree is over 1. Oh, let me just rewrite that. That's a mess. All right, so x to the minus third is x to the minus third over 1. And remember, with negative powers, we dive under. So it will be 2 over 3 times 1 over, there's an invisible 1 there, 1 over x to the plus a third. And how do I multiply fractions? Numerator times numerator over denominator times denominator. Plus, I do not leave the fractional power form. I change it, remember, back to third. So it'll be x to the power is 1 and the root is 3. That is how you write your final answer. Okay, so you have to get used to changing backwards and forwards between third form and exponential form. Right. And I'm going to do a few examples, so just to practice it and make sure that you know how to do it. All right, so if we go through this again, we bring the power forward and we subtract 1. We get minus a third in the power. This is the derivative. That is what the derivative is. But we do not leave it with a negative power, and we do not leave it with a fraction in the power, right? So what we're really doing is we're saying, okay, what do I do with a negative power? I dive. Now, I've shown you the steps how to do it, but actually all you need to remember is that if I've got something like a half x, that x belongs with the 1 because it's over 1. So this belongs with the 2. If I then want to change that to a positive, I dive it under to the 3. So I look at that and I go, that's with the top, I'm going to dive it under. So it's 2 over 3x to the plus the third. And then I change the third, x to the third to third form. Right. Okay, we're going to do another example of that because I know it's a bit confusing, but it's very important that you know how to do it. Okay, 3/4 root x. Yes, let's do that one. 3/4 root x. I want to find the derivative, so y prime. If I have a constant in front, I just keep it there all the way down until the end, and then I multiply it in. Okay, so a constant just stays. I'm definitely going to change my root x to x to the power over root. Invisible 1 over, and just root is invisible 2. Okay, I can't actually do anything to find the derivative if I've got third form. I have to change it to a power first. Okay, so what am I going to do? I'm going to move the half forward. So it'll be 3/4 times a half. X remains always, and then a half minus 1. So power forward, multiply, keep the base, and then a half minus 1. If I work out that fraction, it will be 3 over 8. x to the a half minus 1 is minus a half. Right, and do I like negative powers? Definitely not. I know that that belongs with the 3 because it's over 1. I need to dive it under to the 8. So it will become 3 over 8, x to the plus a half. Okay? Remember, the x and the half are glued together. You cannot separate the x and the half. The only thing that changes when you dive is that negative power changes to a positive. And that becomes 3 over 8. And x to the half, it will be x to the 1. And the over 2 means the square root. That is your final answer. Get used to always making sure that your final answer is written in third form again, right? And in order to write it in third form, you first need to change to a positive power if necessary. I see someone raised their hand.
Yes, ma'am, I did.
Hi, Dianne.
Good evening, ma'am. Ma'am, excuse me, I have a little question.
Yes.
Ma'am, when it comes to changing the negative power into a normal power by like doing the inverse, ma'am, doesn't the whole thing actually change? Like, for example, ma'am, like if it was negative 1 over 3, won't it become now 3 over 1?
No. The value doesn't change. So if it was x to the minus a third, you change that to the 1 that's in front over x to the third. That value and that number, the x base and the power do not change. The only thing that changes is the negative sign, changes to a positive.
Thank you, ma'am.
Are you also sneezing? I think we both.
Yes, ma'am.
It's driving me mad.
It's terrible.
All right, so just remember the power doesn't flip as well, okay?
Thank you, ma'am. Thank you.
Pleasure. All right. Okay, let's do one more. 2 fifth root x cubed. And I want to find the derivative. Okay, now I've shown you that there's one way to write a derivative as y prime. Another way is to write it as dy by dx. That's another way of writing derivative. Dy by dx. It means the derivative of y with respect to x. Derivative of y with respect to x. All right, so dy by dx. It means that the original must be in the form y equals, which so far all of them that I've done with you have been. So you're taking the derivative of y and y equals something. And with respect to x means that the variable is x. Okay, so in other words, if I had dy by dA, then the original would have to be y equals something like 3a squared. The variable would have to be a, not x. We generally use x, but we don't always use x. You'll know from physics that you can have other variables besides x. All right. Okay, so let's go back to this example. What we're really trying to do is find the derivative of that. And remember, we cannot find the derivative until that is in fractional power form. We keep the constant x and then to the power of 3 over the root 5. Right, so that is how I rewrite that. 2 is just a constant, and then x to the 3 over 5. I'm now ready to take my derivative. Okay? Right, so the derivative of a power function means bring the power forward and multiply. So it'll be 2 times 3 over 5. Keep the x to the 3 over 5 minus 1. So power forward, subtract 1. 2 times 3 over 5, remember that is over 1, so it's 6 over 5. And then x to the, and 3 over 5 minus 1 is minus 2/5. Okay, if you work out 3 over 5 minus 1, you'll get minus 2/5. That is the derivative. However, we do not leave it with a negative power. So the first thing we have to do is dive. This automatically belongs to the top, to the 6, so we're going to dive it to the 5. So the 6 stays on top, and then the 5 gets the x to the plus 2 over 5. Just let me rewrite that. Doesn't look good. 2 over 5. And then I do not want a fractional power, so I know that I need to change it. X to the power is on top, and the root is at the bottom. So it's 6 over 5, 5th root of x squared. And you guys can go and practice this and make sure that you are happy with the process, okay? Practice it over and over again. Go through the slides, write down the question, you know, when you get the recording, write down the question and practice it so that you really, really, really get the hang of it. I want to just point out another way of writing derivative is the following. Okay, if I wrote this, this means the derivative with respect to x of that. This is a different way that they can ask you to find derivative. And you need to know the different ways, okay? Right, so the derivative of all of this. Once you take the derivative, you do not write the d, okay? So you're literally going to take the derivative of x to the 3. So bring the power forward, subtract 1. 3 minus 1 is 2. Derivative of an x is its coefficients. Pi squared is a constant squared, which is still a constant. The derivative of a constant is 0. And that is your derivative. So this d with a subscript x means find the derivative of these terms. All right. Now be careful, because if I'd given you something like this, and I said find the derivative, please make sure that every single term is ready to take the derivative. This is not ready. So then we would repeat this. We'd say, I still need to find the derivative of x to the 1 over 2. Because I haven't taken the derivative yet, all I've done is I've rewritten the root x in a different way so that I can take the derivative. Now in the next step, I take the derivative, so I don't write that. The derivative of x to the half, power forward, subtract 1. The derivative of minus 1, 0. Right, so that is the derivative. I do not want a negative power. It belongs on top, so I dive it to the 2. So it's x to the 1 over 2. Okay, so the minus changed to a plus, and then I write it back in third form. X to the power is on top, 1 over the root. And remember, if the root is 2, I don't write a 2. And if the power is 1, I don't write the 1. All right, so this is purely simplifying the answer, that's actually the derivative. All I need to do is rewrite it in a better way. And what I wanted to point out here is that do not take the derivative of some of the terms if they are not already. I can take the derivative of -1, but I cannot take the derivative of root x yet. I first need to rewrite it in a form that I can take the derivative of. And once that's all ready, every single term here in the bracket is ready, then I can drop the derivative and actually take the derivative and write down the answers. Right, any questions so far? Anything worrying anyone? Right, so basically what I've done is I've said, if I have y equals, I can either write y dash or I can write dy by dx. That means derivative, okay? Or I've got derivative of something, and then I can just write down the answers. There's another way. If they give it to you like this, which they often do, they give you a function f of x equals x cubed, say, and they say find the derivative, you write it like this, f dash of x. Okay, you just put that little dash, so it's similar to that. 3x to the 2. Right. I just want to do one example quickly if I can. Right, so f of x equals, oh wait, there are questions. Right. Dianne. Hi. Dianne, are you going to ask?
Hi, this is Yakira.
Sorry, I didn't hear you.
This is Yakira.
Okay, Yakira, you can ask. Sure. Okay, I see. All right, I understand. Okay.
I've seen a question where it was d of x over d of y, and I'm not sure if that's a different notation
Yes,
or what.
it's a different notation. Correct.
But does it mean the same thing?
It means the same thing, yes. So these are the different ways that you can write it. You can either, if they give it to you as y equals something, you can write y dash as your derivative, or you can write dy by dx. Means the same thing.
I don't think you understood what I meant, Matt. It was d of x over d of y. So it was like the opposite way.
No, it's got to be, the y must be on top. So if it's y equals, the y goes on top, and the x's on the other side go at the bottom.
Okay, ma'am.
So if it's y equals, the y goes on top. The x's will be here. They go at the bottom.
Okay.
Yeah. So in other words, if I gave you something like k equals 2p to the 4, if I wanted the derivative, it would be dk by dp. Okay, the k equals goes on top. Whatever's here on its own goes on top, and the variable on the other side goes to the bottom. So it would be 8p cubed.
Okay. Thank you, ma'am.
No, it's a pleasure. All right, I just want to do one question. Okay, sorry.
Can they ever give you, say, x in terms of like x is equal to 2y4, just to trick you, because it's still letters?
Technically, yes, they could. So then it would be dx, because it's x equals, by dy. Yeah. So it would be 8y cubed.
Okay, thank you.
All right. They don't tend to do it, but technically they could. And I have actually seen it once or twice over the years. All right, so f of x equals, let's see, 2 pi minus the 4th root of x the fourth root of x. Right? So if I want to find the derivative of that, because it's f of x, I write the derivative as f dash of x. That's the only way I can write that derivative. If it's given to me like this, I have to use that notation. But now, do you see that I can easily take the derivative of 2 pi? It's a constant, right? But I can't take the derivative of that yet. So before I do anything, I have to first rewrite this. So I can't write f dash x equals and then change the form. I have to first change f of x to the correct form. So x to the 1 over 4. And only once you've done that, then you are ready to find the derivative. So this step, all you've done is rewrite the fourth root of x. It is still f of x. Only then are you ready to take the derivative. The derivative of a constant is 0, and then power forward, so it's minus a quarter, x to the quarter minus 1 is minus 3/4. All right, so you can't write f dash x if these things are not already ready to take the derivative. That wasn't. First change it, it's still f of x, you've just changed the form, then you write f dash x equals. They will subtract marks if you write derivative in the wrong place, okay? You can only write derivative when you're actually doing the derivative, okay? Like here, we brought the power forward and we subtracted 1. So that is the derivative. And then I'm going to rewrite that. So remember, this belongs on top, so I dive it to the 4. So it's minus 1 over 4, x to the positive 3 over 4. And that I can rewrite as 4x to the 3 fourth rooted. The over 4 is the root. And that is your final answer. All right, so that is a little bit of a recap of, well, not a recap because I didn't realize that you hadn't done it at all yet. I would be super pedantic about doing calculus quite soon in the year, simply because it forms quite a big chunk of your algebra paper. And it's easy marks if you know the process. If you don't know the processes, you lose a lot of marks, okay? So what I've done this evening, this counts quite a few marks in your exam. They literally will just give you any variation of what I've given you this evening as a couple of questions in your exam. Find the derivative. So they could literally give you a question like this. And it would be like 3 marks. And then another question could look like similar to one we've done before. And it's another 3 marks. And before you know it, it's 6, 7, 8 marks just on finding derivatives. So as long as you know the processes, you're A for away. And then you've got marks in the bag. And there's always a section like this in your exam paper. Find the derivative. And they'll either give you 2, 3, or 4 questions to find the derivative of. Okay. And I'm going to be elaborating on this next time. So on Monday, I'll be carrying on with this. So I'll do a bit of a quick recap of it, and then I'll carry on, because this isn't the only way that they can ask it. They can ask, there are a few other ways that I need to point out to you that they can ask as well. And if you know all the variations, there's nothing that they can give you that you won't be able to get the marks for, which is awesome. So actually calculus, it seems to be such a scary word, but it's actually personally my favorite section. And the reason why it is my favorite section is because it's got lots of applications that make sense when you go deeper into it, like we are going to do for your syllabus. But it's actually very learnable. You can learn how to do it. And then those are easy marks in your exam. Okay, so there we go. That's about it from my side for today. And then I'll see you on Monday. I'll carry on with calculus. I'd like to complete the whole section. Like I said, it's a huge chunk of your algebra paper. So that's why I felt it was important to do calculus and get that done so that you are comfortable with it, that you can practice it and know you're going to get these marks. Super. Thank you so much.
Thank you very
Ma'am?
much, Dianne.
A pleasure. And then I shall see you on Monday, same time.
Okay.
Bye, guys.
Thank you, ma'am. Bye-bye.
Pleasure. Bye.